Hello everyone, welcome to my live. Welcome. Okay, let's continue routing network. And we were here. ICMP6 neighbor discovery. Internet Control Message Protocol for IP version 6 is similar to ICMP for IP version 4. Like ICMP for ICMP version 6, use information and error message for testing layer 3 connectivity and to inform the source and any issues such as the network is unreachable. ICMP version 6 is also much more robust protocol than its IP version 4 counterpart, as it includes IP version 6 neighbor discovery protocol as described in RFC 4861. ICMP version 6 neighbor discovery is used for automatic address allocation, address resolution, and duplicate address direction in IP version 4. ICMP version 6 neighbor discovery includes 5 messages. Router solicitations are sent by a device to all IP version 6 routers multicast to request a router advertisement message from the router. Router advertisement RA sent by an IP version 6 router to the all IP version 6 device multicast includes link information such as prefix, prefix length, and the default gateway address. The RA also indicates to the host whether it needs to use a stateless or a stateful DHCP version 60 server. Neighbor solicitations NS sent by a device to the solicitate node multicast address when it knows the IP version 6 address of a device but not its Ethernet MAC address. This is similar to Address Resolution Protocol ARP for IP version 4. And neighbor advertisement NA sent by a device usually in response to the neighbor solicitation. Let's out how to pronounce this because I don't know how to pronounce.
Solicitation.
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 Solicitation. Solicitation. It's hard message. Sent as unicast, it informs the recipients of its Ethernet MAC address associated with the IP version 6 address in the NS message. Redirect. This is similar functionality as in IP version 4, sent by a router to inform the source of packet of a better next hop router on the link that is closer to the destination. Network types. Not all layer 2 network topologies support all traffic types because unsupported traffic types influence the operation of routing protocols. It is important to be aware of the limitation of a specific network topology. As shown as in figure 1.8, there are 3 generation network types described further in the list that that follow. Okay, as we discussed, here we have a point to point, which means there is nothing between two devices, for example R1 and R2. We have here we have a direct traffic. Okay, broadcast, which means we send data and traffics to all nodes in our networks. Also NBMA. Look, we have a three different traffic. Look, and they all have a different destination. For example, it goes here, and this goes here, and this goes here. Actually, we send three different traffics at the same times. However, they goes in different destination. Point-to-point network, a network that connects a single pair of the routers. A packet that is sent from one end is received exactly by one reception on the other end of the link. A serial link is an example of point-to-point connection. So here it says we have a serial interface with a with point-to-point. And broadcast network, what is that? A network that can connect many routers along with the capability to address a single message to all of the attached routers. Ethernet is an example of a broadcast network. Non-broadcast multi-access, NBMA network, a network that can support many routers but does not have a broadcast capability. The sender needs to create an individual copy of the same packet for each reception if it wishes to inform all connection neighbors. Also, the sender must know the reception address before packet can be transmitted. Frame relay and this transfer mode ATM are example of an NBMA network. Let's put donation link though. Welcome guys. Perfect. While point-to-point and broadcast networks do not present any difficulties for router protocol, NBMA network introduced several challenges. Routing protocol need to be adapted through configuration in how they perform neighbor discovery. The instance vector protocol need additional configuration, which also change the default behavior of how routing information exchange between neighbor. This is due to the loop prevention mechanism split horizon that prevent the transmitting of information that is received on a specific interface from going out of that the same interface. NBMA network. NBAM networks can be used a variety of topologies. The most common are hub and spoke or partial mesh topology. Let's see what is partial topology. You can look it. Hmm. Hub and spoke. It's like hub and it's like oh, this is okay. This is because full mesh topology do not scale well and can become very expensive with a greater number of interconnected locations. Frame relay technology is the most common example of an NBMA network. What is frame relay technology? Good question. Okay, it says frame relay technology is a packet switching network protocol that operate at, let's zoom in, at the data link layer of the OSI model. It is designed to connect local area and transmit data across the wide area networks. Frame relay is a better alternative to point-to-point network for connecting multiply nodes that require separate dedicated link to be established between each pair of nodes. Hmm. There are sorry, there are several options for how you can adapt routing protocol to support operation in a frame relay NBMA hub and spoke network. If you use a single frame relay multi-point interface to interconnect multiply sites, reachability issues may be a problem because of the nature of a frame relay. The frame relay NBMA topology can cause the following issues. Disadvantage 1. Split horizon. For distance vector routing protocol, the split horizon rule reduces routing loops. As illustrated in figure 1.9, let's see. Hello, welcome. Let's see what is this. Like forwarding of the same routing. Okay. Now I remember. Okay. As illustrated in figure 1.9, it prevents a routing update that is received on an interface from being forwarded out of the same interface. In a in a scenario using a hub and spoke frame relay topology, a spoke routing sends an update to the hub router that is connecting multiply permanent virtual circuits (PVC). over a single physical interface. The hub router received the update on its physical router face, but cannot forward it through the same interface on the other spoke router. A split horizon is not a problem if there is a single PVC on a physical interface, because this is type of connection would be point to point. Hmm, good idea. Such a good idea. Now I'm thinking about it. Let's focus exactly what happened here. Okay, it says R1, for example, block forwarding of the same routing update. Neighbor discovery. OSPF over NBMA network works in a non-broadcast network mode by default, and neighbors are not automatically discovered. You can statically configure neighbors, but an additional configuration is required to manually configure the hub as designated router (DR). OSPF treats an NBA network like Ethernet by default, and on Ethernet, a DR is needed to exchange routing information between all routers on a segment. Therefore, only the hub router can act as a DR. Only the hub router can act as a DR because it is the only router that is PVCs with all other routers. Broadcast replicate. With the router, the support multi-point connection or a single interface that terminates as a multiply PVCs. The router must replicate broadcast packets such as routing update broadcast on each PVCs to the remote routers. This replicate broadcast packet consume bandwidth and cause significant latency variation in user traffic. So on each PVC to the remote routers, this replicate broadcast packet effect on bandwidth and latency. It's important. When a router is connected to multiple physical locations over a WAN NBMA link, you can use the logical subinterfaces to transmit multiple virtual circuits on one physical interface. Subinterface also overcomes some limitation of NBMA networks. You can choose between two different types of subinterface. So we have two options: point-to-point subinterface and point to multiply subinterface. Let's see what the difference between them. Each subinterface which uh, which provide connectivity between two routers. Okay, use its own subnet for addressing. Okay, from a, a per, from a perspective of routing protocol, connectivity looks just like a several physical point-to-point links. Mm-hmm. Here, go for this. Hmm. Okay. And it says, which means there are no issues with the neighbor discovery and the split horizon row. Figure 110 shows an example of point-to-point subinterface. This is. And what is point to multiply subinterface? One subnet is shared between all virtual circuits because private address space is normally used for addressing. Saving address space is not a significant bandwidth because both EIGRP and OSPF need additional configuration to support the underlying technology. Point-to-point subinterface are preferred and recommended choice. Routing over the internet. You can select among several different options and technology when choosing how to interconnect remote location with a central location such as headquarters site. One of the options is to rent interface connectivity, which is usually a less expensive alternative. There are several reasons why IGP routing protocols are not used to establish connection over the internet. Okay, we have several reasons why IGP routing protocol are not used to establish connection to internet. All IGPs establish adjacency. Okay, let's search for we search everything.
Adjacency.
Adjacency. What does that mean? Adjacency. Okay. All IGPs establish adjacency only between directly connected neighbors, rather that are connected over the internet or several hubs apart. Typically, within an organization, you use private IP version 4 addressing, while packets that are sent to the internet get routed only if public IP version 4 addressing is used. If you would wish to route internal traffic between remote location over the internet, you would need to use NATs extensively. Rely on NAT in this scenario introduce great complexity as both the sender and receiver IP version 4 addresses need to be translated to public version 4 addresses. The internet as a transport medium cannot be trusted. Anyone who is a part of the transport path can eavesdrop, eavesdrop, or modify data without additional security mechanism. The internet is not suitable to exchange private data. To overcome the described obstacle, different tunneling mechanism can be used to extend a private network across the internet. Although there are several different technology involved, they are generally named virtual private network, as we know VPNs, which enable the exchange of information as if remote hosts would be connected to the same private network. The majority of VPN technology also support routing protocols. Neighbor adjacencies between router are established over tunnel interface, which are created when VPNs are established. VPN technology are well integrated with additional security mechanisms which provide suitable authentication, encryption, and anti-relay protection. Guys, let's see what is anti-relay protection. Anti-relay protection. I think we have this on IPsec. Is a security feature that prevent an anti huh, that prevent an attacker from masquerade resending a delaying valid data packet, often called relay attack. Oh, I remember. Now I remember. It's like this. It works by using sequence number on each packet and a receiving system that track this number to reject duplicate or old packet that fall outside sliding windows. Packet number, data integrity tracking, receiving packet, packet validation. Now I see. Well, connecting remote location with headquarters. To connect remote location with the headquarters, there is no longer a need to use only traditional solutions such as leased LAN or friendly connections. Newer technologies such as multi-protocol label switching, MPLS, VPN, and DMVPNs are now with the spread because they are offer more flexibility at a lower cost compared to the traditional solutions. It is important to be aware of these new VPN types because they are also influence deployments and the configuration of routing protocols. Upon completing this lesson, you will be able to do these and this. Okay, guys, we are in a 54 pages and this chapter will continue until 89 page. It's good. We can finish it. Okay, guys, I think this is enough for today, and I will be come back at tomorrow. I think. See you later. Have a good day. Thank